So this video is just a bunch of setup and then a bunch of integral calculations. So there's really not that much new once we have our formula. Understanding how the formula works is important, but I don't think this video should be too bad. Let's do example 2. Calculate the arc length. In this section, I might abbreviate arc length AL. I might not, but if I'm being lazy, that's what it is. Calculate the arc length of f on the interval a to b. All right, part A, f is going to be 2 times x to the 3 halves, and our interval is going to be 0 to 1. So again, we could graph this. We don't need to graph this, but we could graph this and get a picture. I'll set up the integral and then I'll graph it. So again, we can use that formula, take it over. It's just the integral, arc length, also known as S. It's going to be the integral from a to b of the square root of 1 plus f prime of x squared dx. So we just plug things in. That's it. Integral 0 to 1, square root of 1 plus the derivative square. Oh, okay, we need the derivative. Let's go off to the side. What is the derivative here? It's just the power rule. So the 2 is a constant multiple. Bring down the exponent and subtract 1 from the exponent. So you get 3 times the square root of x. And remember, the square root of x squared is x. Again, the inverse, the backwards order of that, the converse, if you will, sometimes has absolute values depending on the domain. But here, that's all we need. Plug in f prime. F prime is 3 times the square root of x. We're squaring that and evaluating this integral. That's it. All right, so I'm not gonna do these right now. I'll do this at the end of the video if you want to see it, but I recommend pausing it and doing it on your own. Okay, and I'll work through them at the end of the video just in case. And again, if you want some context about what's going on here, you can visualize it. 2x raised to the 3 halves is this curve, and we're looking from 0 to 1. So all the way up, what is the arc length of from the start up to here? At a very, very, very rough guess, right? It looks like we go right 1 and up 2. We could approximate it by the square root of 5. Let's see if square root of 5 is close to our answer. We'll find that answer at the end. Okay, but again, pause the video, do this problem. I'm not going to do it right now. Part B. F of x equals sine of x on 0 to pi. So again, it's the exact same thing. Just use the formula. Okay, the arc length, we usually use S for arc length, but you can write whatever you want. Arc length is the integral from 0 to pi of the square root of 1 plus its derivative squared. What's the derivative? Cosine. All right. That's all we're doing here. We're just using this formula. Okay, so when we do that, we simplify it out. 0 to pi, the square root of 1 plus cosine squared of x dx. And we know cosine squared of x is 1 minus sine squared of x. But the ones aren't going to cancel. And remember, we can't take the square root of each thing individually because there's addition between them. We can't really simplify this. We can't really do this integral. Okay. And that's going to pop up in this section. So in a lot of the problems in this section for the homework, it'll say, calculate this by hand if you can. Otherwise, use a computer. So we'll be using Desmos for these ones that cannot be done by hand. All right, in class, I'll either let you do it by hand, I'll either make sure it's possible to do by hand, or I'll just tell you to set up the integral and not evaluate, okay? Let's get some practice doing what it wants us to do in the textbook, and let's evaluate this integral from 0 to pi of the square root of 1 plus cosine of x squared dx. You can type that into Desmos and get an approximate answer, 3.820 units. Again, this is a length, so we're going to try to use units whenever possible. Which again, to visualize this, all right, this is sine of x from 0 to pi. What is this arc length? And again, we could approximate it by just drawing a triangle with height 1 and width pi. And then what's the sum of these two sides? If you approximated it that way, all right, this would be pi over 2 by 1. So we could approximate it by the square root of pi over 2 squared plus 1 squared. And then the second piece will be the same. So we could approximate this, like visually approximate this total arc length with Pythagorean theorem and get a pretty decent approximation, 3.82, 3.72. Okay, not too far off. But if we actually wanted the full arc length, it's going to be a little bit bigger. And in fact, it will always be a little bit bigger. No matter how many pieces, we use 2 pieces here, 3 pieces, 4 pieces, any function, our approximation with lines will always be smaller than the true value. So that's the end of this video. If you want to stick around, I'll spend a moment and calculate this integral, but that's the end of the video. Okay, so simplifying this integral, this is 0 to 1, square root of 1 plus, when we square something like this, there's no addition or subtraction, so we don't have to FOIL. We just square each term. Now we can't take this integral yet. We need to use a u substitution. We're going to go off to the side and say let u be the inside, 1 minus 9x. Du dx will be 9, so du is just 9 dx. That means we need a 9 out in front. We'll compensate with a 1/9. And that'll give us a 1/9 times the integral from, oh, it's not from 0 to 1 anymore, right? We're doing a u substitution. So if x was equal to 0, that means u is going to be 1. 1 plus 9 times 0. If x is equal to 1, that means u is going to be 10. And now we're going from 1 to 10. And again, if we just look at this, the 9 plus the dx, well, times the dx, that's our du. So the blue stuff just becomes our du. And what are we left with? Well, 1 plus 9x is u. We're left with the square root of u. We can write the square root of u as u to the 1/2. Using the power rule, we add an exponent and divide by the exponent. And that's evaluated from 1 to 10. Be very careful here. This is in u, and this is in u, so we don't have to substitute back into x. Now, if we didn't change the limits, or if we were doing an indefinite integral, we would need to substitute back into x. But because it's a definite integral, we already took care of that. That's going to give us 2 over 27. And then this becomes 10 to the 3/2 minus 1 to the 3/2. 1 to any exponent is just 1. And this is our exact answer. There's no real good way of simplifying this. All right. So we compare our answer. Our estimate was a square root of 5. The question is, how close is this to the square root of 5? Whoa. So we found it was 2 over 27 times 10 raised to the 3/2 -1, +1? I don't remember. -1. Oh, look at that. It's close to our estimate. And again, it's a little bit bigger. Our estimate should always be a little smaller than reality. There we go. That's our final answer. Units long. You could give a decimal approximation here as well. I'll try to be very clear about what I'm expecting for these. Let me know if you have any questions, and good luck on the problems.